Awesome, thank you. So, yeah, as Kosa said, uh, this conference, we're spending a lot of time talking about things that people are building with Flink. We're talking about diving into the internals, right? I know Till earlier today had a really interesting talk on schedulers and Flink runtime. But this is an open source project, and so uh, a lot of the fun is in the community. And I know I've personally gotten a lot out of being involved in the open source community. I want to show other people how to as well. Flink is one of the most active of any Apache projects, and so it's a great one to get involved with. So today, I wanted to take some time to talk about the code contribution to Flink, right? The processes we have in place. Dive through the code base a little bit, right? How do you? It's a big code base. There's, I think, I counted last week. There's something like 500 million lines of code in the repository. So how do you get acquainted with that? How do you find things? And then there's a little feature I've been wanting to add for a while, and so I thought this would be the perfect time to do it. Yeah, please use the chat. I want this session in particular to be as interactive as possible. But otherwise, let's get started. So, we are an Apache project, and so that means we follow the ASF guidelines for contributors, committers, and PMC members. So if you're not familiar, PMC members are kind of the board of trustees of the project, so to speak. They are they make the big decisions about the direction of the project. They have and they are the ones that vote on releases. So they determine whether or not to release a new version if it meets the community standards. Committers are anyone who has write access to the repository, so anyone that can merge in new features. And they come from active members in the community, people that have made some number of code contributions that we feel have the best interests of the project at heart. And then there's contributors, and that's everyone else, right? And so contributors are the ones that really power this community. They're the ones that are building these features, and we wouldn't be here without them. So the repo, right, we do all of our development on GitHub, so it's pretty easy to find, and is actually, I believe the ASF recently said we were the most viewed repository of any Apache project, so that's pretty exciting. And we follow a fairly standard workflow. So if you want to get involved, the first thing I would recommend is to sign up for the dev mailing list. All development happens there. It is where we discuss changes. It's where we vote on changes. And if you're thinking about getting involved, I would highly encourage you to subscribe and just start to see what's happening. Big changes, so things that might require, say, a design document or change the direction of the project in some way, go through a process called FLIP, so Flink Improvement Proposal. And that is where you lay out your proposal for what you want to do, explain the pros and cons, how you ended up on this, and then there's a lively discussion on the mailing list before we vote. When that vote is accepted, then we begin working on the change. Individual contributions go through Jira, so we use the ASF managed Jira. And that is kind of our gatekeeping process, because this is such a large project. We have so many contributors that we need some way to keep a handle on the contributions coming in to ensure that there is bandwidth to review them, right? I don't want anyone to go and spend a lot of time building something just so that for there not to be a committer available to review that change. So what we as a community have decided is that we create tickets on Jira, and then only committers are able to assign tickets. And in assigning someone a ticket, that committer is agreeing to guide them through the contribution process, review that change, and kind of walk with them through the full step. And so that's the basic guidelines. If you go onto the Flink website, flink.apache.org, there is a very in-depth contribution guidelines. It has our coding style, our standards, walks you through this entire process in detail. But if you're ever in doubt, please just, again, reach out on the ML. So that's enough talking. Let's look at some code. I think I have Flink pulled up in IntelliJ. And as I mentioned, it is a big project. There are a lot of modules here. And you do not need to know everything to start going through this code. I have been involved in this project for a number of years now, and I still don't know half of these things, right? People end up specializing in different components. So, some people spend a lot of time working on the table API, and they know that in and out. And then other people focus on the resource manager. So, for instance, there is a module that contains all of Flink's Yarn integration, and I could not tell you much about what is going on in that code base. But that's okay, right? There's lots of places to contribute. And so just a general sense, right, we have Flink runtime that is maybe the core module. This is where the network stack lives, and our state backends and checkpointing and all those good things that really make Flink Flink. There is Flink streaming Java, which is the module you are likely most familiar with. This is the one you actually include in your POM file when you're going to write a data stream application. We also have things like Flink table, and this is where all of the table planners live, the SQL runtime, the parsers, all of that good stuff. And so often I will go ahead and actually unload a lot of these modules. So I rarely, if ever, work on the table API, and so I don't even want that in IntelliJ. It's just taking up indexing time. And it's also good to have your CI/CD set up. So running the full suite of tests that go on every PR locally on my laptop would take, I think, 3.5 or 4 hours if I just ran Maven test. You really want to be doing it on your CI pipeline. We use Azure Pipelines. And so you can set that up for free. You can link that to your GitHub repository and easily get started. Otherwise, locally, I typically only run the specific tests inside of IntelliJ that are relevant to the change that I am making. Okay, so what are we going to do today? There's a feature I've wanted for a long time. I want a way to collect results from a data stream. Right? I want to be able to take the data from a data stream application and pull it into a list, or it's actually going to be an iterator in this case, so that I can work with it locally. This will be really convenient for local testing of my pipelines. I think this is something that users could really need. And also, if you've been paying attention to ongoing development in the community, you know that we are adding batch support to the data stream API. So you can run your data streams in bounded mode, and collecting results from a bounded pipeline is a very useful feature. So I've gone ahead, I've just defined the method signature, and I have defined a little test just to have something to get us started. So this is test, start, stream, and collect, and we are going to just have a couple elements and then call collect on them and ensure that we did in fact collect all of those items. Some things to notice here about the way that we do our testing, right? So we really like JUnit, we really like Hamcrest matchers. So I'm checking to see that yes, I am in fact collecting all of these, and I get a good error message when something goes wrong, because again, there are a whole lot of tests, and so if something fails, a contributor that may not be familiar with this part of the code base needs to understand what is going on so they can at least surface the issue to the correct person. The other thing that is maybe relevant for this change in particular is this is collecting records from the task managers and pulling them to the job manager. And if you think about what that entails, right, there is network there intrinsically, right? Task Manager is a different JVM. And so for a proper test of this, we want to actually ensure that we are really pulling records across the network correctly and that all of that is working. And Flink contributors and committers have added a lot of testing resources specifically for the project, though some of these you can use in your own code base if you're just building applications. And so one is this mini cluster with client resource. So this is a standard JUnit class rule, and it allows us to actually instantiate a Flink cluster that is going to be used when we call stream execution environments .get execution environment. So this way, it's not doing local execution, but actually deploying against a real cluster that just so happens to be deployed locally. And so we get to test that serialization is working properly and that network is working properly. The other really nice thing about this, just from a quality of life perspective, is actually bringing the cluster up and tearing the cluster down is typically the longest, most time-consuming portion of any test in this code base. And so by using a class rule, we can have a predefined cluster that is used across all tests, and it just makes our lives a little easier. Okay, so let's take a look at this. So I'm not really starting from scratch today. That would be a bit too much to do in a bounded amount of time. But there has been this feature in data stream utils for a while for collecting. And data stream utils is where we put experimental features. So someone wants to try something, but we don't want to make any guarantees about stability. Maybe we don't know that it quite works yet. And so collect is one of those things, right? Hey, I think this is something people would like, but I don't know that it's going to work. And it's been here for a number of releases. It has really stabilized, especially in 1.11. And so now we have decided that we want to promote this to be a first-class feature of the project. And so we want to actually add it to DataStream. But I want to make a couple of changes. So first of all, when we look through here, you can see there's some weird kind of hacky things like throw this as an unchecked exception because we don't want to break backward compatibility. Well, I'm moving this method, so we get to make that change. We also want to ensure that we are properly closing our resources. So we are setting up clients that are going to talk to the job manager and task manager. And currently, we are simply returning an iterator over this data. It's an iterator versus a list because data streams are unbounded, and so we need a way of returning unbounded data locally. But this is actually leaking resources, and so I have gone ahead and replaced it with a closable iterator so that we can be good stewards of our resources and ensure that everything is properly cleaned up. We can take a look at what this is really doing under the hood. I think it's kind of interesting because it's collecting this data in a what I think is a very novel way. We have data on the task managers, right? We have our data flow DAGs and pipelines run through, and they eventually get to that sink that is running in some task slot. But we want to get that back to our user code that is running on the job manager, right? When you build up your data stream, when you call environment.execute, that's running on the job manager. And that means network. And network is expensive. Network takes bandwidth, right? We're doing lots of things on the network. And so the question is, could we somehow reuse network that already exists? Well, of course, what's the word I'm looking for? The job managers and task managers are already communicating with each other, right? They're sending things like heartbeats, they're sending metrics. And so the person that implemented this did something that I think is very clever, and that they're piggybacking on those heartbeats. So if you're familiar with accumulators, they are a way of doing kind of cheap metrics inside of Flink. They send values that piggyback on the heartbeat messages from the task manager to the job manager. And you can put arbitrary data there. Typically, it's just little counts. But in this case, someone has written a sink that is going to serialize records into accumulators, and then that is going to get shipped back to the job manager for free, right? We already have that infrastructure in place. So that is what this code is doing right here. It's very little compared to, it's adding very little on top of what Flink already was providing out of the box. So let's go ahead and start to take a look at this. I said this was going to be a live code contribution, so we really are going to do this live. First thing that I noticed taking a look is that it has this helper type, client and iterator. It's a static final class inside of data stream utils. Well, we're migrating this, so I want to make it a full-fledged class. We want to go ahead and move this inner class. I'd like to move it to the upper level, but I don't want it to go here. Flink streaming API data stream. Well, this is, let me scroll to the top real quick so I can have some IntelliJ help. This is where most users are pulling in from the API, right? This is very much a public package inside of Flink. This is where data stream lives. This is where keyed stream lives. I don't want my helper class here. But I was taking a look and I noticed that there is this other package where we are hosting all of the other runtime components of this collect feature. So let's go ahead and move it there. I'm going to go ahead and copy this package, and then we will refactor this. Let's move this in our class. Let's move it to the upper level, and this is where we want to go. So I will let IntelliJ do its thing, and we are going to move that class over. So that should, there we go. So I'm not going to add this to Git right yet. So we have moved this class into this new package. So it is no longer a static class, but it's something we can use externally. And it is holding on to both the iterator that we want to use to retrieve our data, along with the job client, which gives us direct control over what the job manager is doing. And so it's just a little tuple helper type. But there are a couple things I need to change. First of all, this is now a brand new class. And as with all things in Flink, let's give IntelliJ just a moment to catch up. This is an Apache project, and so we need an Apache software license at the head of every file. Between IntelliJ and streaming video, my computer is, I'm sure, very overworked right now. So I'm just going to copy the license from another file, add that to the top. And then there's one other change I want to do. This is a public class, right? So that's standard Java, meaning it is exposed outside of the package. Anyone can see this class. But it's only public because Flink is a massive code base and I need to access it within some different sub-packages. It's not that I actually want this to be a stable component of Flink's API. And so to be able to have this flexibility as a developer, along with offering good compatibility and well understood compatibility guarantees to our community, we have some annotations we'll use to signify things as being internal. So often, if we need to mark a class as being public for Java reasons, we will add this @internal annotation, which is our way of communicating that, yes, I understand you can technically see this class, but this is an internal implementation detail. See nothing, right? Pretend this is not here. So we've added that. I've added our license file. We also have check style, right? So we want to ensure that our code looks consistent with the rest of Flink. So I like to run this on a per file basis, and we'll quickly scan the current file. And I suspect, because I did not make any real changes, that this is going to come back and say no problems found here. So I feel pretty good. Okay, so we've made that change. And let's go ahead and copy out some of this code. So I'm just going to take this wholesale as is, execute, and collect. The other thing that I did, I made a change. I went from collect to execute and collect because most things in Flink are lazy, most operations. And so I would like to be very explicit that this one is not. When you call this, you are actually going to be submitting your job, and it is going to trigger computation. I'm going to go ahead and just paste that all in here. Let's see. So I need to go ahead and replace T with out with T. Let's make those changes right here. And there are a few other things. So I have job execution name. I'll just keep that. I don't have any love for what I had come up with. And stream is going to go away because we are now directly inside the data stream. So just anywhere this exists, I can get the current type. I can get the current execution environment. We can get that execution environment again, and I can pass this into the sink. Okay, so this is pretty much there, right? We don't want to return the full clients and iterator, but I actually want, in this case, just the closable iterator, which is an interface that contains both closable and iterator, right? It just combines those two to say that this thing has resources. And so I'm going to, in this case, just return this iterator directly. And let's see how close this got us. I have a little helper I added that adds a default name because often you don't want to add your own name. And we can run this. I like to iterate pretty quickly in terms of running my tests just to make sure I haven't broken anything. Being a large code base, it is very easy to break something that you didn't realize you were touching. One thing you will find is that Flink's codebase definitely pushes IntelliJ. And so the one thing I did do before starting the session was have it re-index, which is always a great time to go get a coffee or go for a walk. So if we ran this correctly, it should, I hope, fingers crossed, return back with these, return back successfully. And so it should be an iterator that is going to give us these three elements. We will close it when we're finished because we did a try with resources, and then we'll see those three in any order. As I mentioned, this is a test that is actually submitting a job to a cluster, so it is bringing a cluster up, it is submitting, it is tearing it down. So it takes a little bit of time, and so I will continue to vamp. Awesome. So that was kind of the core of it, right? We've made this little change. There's actually one other feature I really wanted to add, though, is I want to add a limit. So often when doing testing especially, or if you're simply iterating on your code, as a data stream developer, you want to just see some of the results. You don't want to run this application forever. And so if we go back, I want to have another version that adds a limit. And so it will say, if you only collect up to 10 elements. And in that case, go ahead and just stop the job. So let's go ahead and add that. I want to copy this code into something slightly more internal. So let me go ahead and copy this. And I'm going to add a private client with iterator T to cute and collect. with our string job execution name. And we will throws an exception. I think that's almost English. And I will paste what we have right here. So it was not client with iterator, it was client and iterator. And we will return a new client and iterator of our job client and our iterator, except I am now noticing these types are not exactly correct. I actually want this to be a closable iterator. And we'll make that change as well. Going back, I can now have, going back into data stream is where I want to be. I'm going to have this and collect with clients. I need a different name here. So I'm going to go ahead and have this return execute and collect with clients with the job execution name, and then just return the iterator. But we can now add our second implementation that adds a limit. So I'm going to copy this. I'm going to add an int limit value. And so it will only return up to X number of elements, and either the job ends before then, or if we return, say, the 10 that we're looking for, we want to simply cancel the job. So in this case, I do really want my clients with iterator, clients and iterator. I will never get that right. And what are we going to do? Well, first thing I actually want is a sanity check. So whenever you are writing something that is a public API, so a method that a user is going to call, we want to check those inputs as aggressively as possible. So that means things like checking for nulls and checking for sane values. So in this case, we're going to use Flink's preconditions, which is how we do these checks. And I'm going to check state, and I want to ensure that limit is greater than 0, because otherwise this just doesn't make sense. And we also want a good error message so that our users, if they make a mistake, understand what that is. So limit must be greater than 0. So we have that. And so now let's go ahead and collect this and do our proper closing of resources. So I need somewhere to, I'm not going to return an iterator in this case. I am going to actually return a list. And so we'll say our list T of results is equal to new array list. I actually know the size, so why don't we take advantage of that? And then say while results dot, not results, while client and iterator dot iterator has next and limit is greater than 0, then we'll go ahead and results dot add that value. So let's add our next value from whatever the task manager is returning, dot next, and limit minus minus. So just some real simple Java code to take advantage of things. One thing you will do, so I want to go ahead and make sure that we have proper exception handling. So inside of a finally clause, we will ensure that we clients and iterator dot close. So we are closing those resources. And we also want to cancel the job. So I have my clients and iterator dot clients, right? This is what Flink's CLI is actually using under the hood to submit and control your jobs. And so I want to go ahead and cancel this job. Let's make sure that everything is properly cleaned up. And at the very end, we will results dot, let's just go ahead and return our results. So we will send back this information. Once again, I want to very quickly check my check style because this is somewhere I get burned constantly as I try to make changes. And you'll see I have a number of errors. So our check style is pretty strict. I think they're up in, no, it is not up there. It is down on line 1,347 because this is a large project. And here it is. So blank lines should not have any white space. Let me go ahead and fix that. There is actually an ongoing conversation about whether or not to add an auto formatter to the project. The reason we haven't so far is that there's a lot of existing code, and the developers of the community very actively use things like git blame to understand when changes were made. And so to go through and reformat the entire code base would kind of ruin that and make it very difficult. But perhaps it's something that'll happen sooner than later. I also think I have a missing, yep, I have an import that I am not using. Let's do another quick check. So close. And I need to get rid of that. So this should work, but there's only one way to test it. I also would like to not have to always specify my job name, though I think it is convenient to have in general. And so let's just add a quick overloaded method to make people's lives a little easier. Oh no, my thing got weirdly formatted. Let's fix this very quickly. I think I can do this more quickly. Nope. Let's see if I can do this very fast so that we're not all sitting here watching me reformat some code. So I'm going to copy that. I'm going to public list t execute and collect int limit throws an exception, and then we will call just return execute and collect with both data stream collect as our default name along with our provided limit. So just a little nicety for our users. Okay, so as with everything else, we want a good test. So I'm going to go ahead and put it in the same place I put this. Because we are using this mini cluster with client resource, things are going to be a little faster this time. We'll add an additional limit, and I'm going to throw in a couple more elements, but I only want to collect one of them. So this is now going to return me a list of results. And this is going to be an integer, and it is also not closable because we are handling that. So I can, in fact, inline this little bit, delete our try, delete this, and then this test, if I made this change, would actually not be a very good test. This seems intuitive, it seems like the thing it should be, but it turns out it would actually be very flaky because I am running this job at Parallelism 4, which is good because that's real world. People run Flink applications at all sorts of parallelisms. However, that means that there is no guarantee on which of these elements I'm going to receive. And so it could be that this works locally and my test passes most of the time, but then occasionally fails. And so in this case, I'm just going to make this an assert equals, and I'm simply going to check the size. So I simply want to know that I got exactly one element, which was what I was limiting for in my application. To collect the correct number, the correct number of elements from the string. And just for the sake of some check style, I'm going to move this down a rung. And let's go ahead and run both of these tests very quickly. So let's see that everything goes through properly. So this is going to do the same thing we did before. We'll see it is doing some compiling, and so I'm going to vamp a little while it's compiling. And then it will bring up a cluster, submit both of those things, and see if we did this correctly. You could heat a home on my laptop as I am both compiling Flink inside of IntelliJ and streaming video. So this is going, the test is submitted, so cluster's coming up. And if we hold our breaths for just a moment longer, I suspect we will see our tests execute. And we will not have this full startup time for both of them as I continue to vamp a little bit. And I will go ahead and talk about something else while that continues to run in the background. Oh, here we go. So let's see. Let's cross our fingers and see that both of our tests pass. They do. Awesome. So I feel pretty good about this. These are the core functionality we wanted to add. Going back into data stream util, while these are marked as experimental, we have that annotation. I still want to be a good steward for the people who might already be using this and let them not simply delete this code. So we will add some deprecated signatures, and we will add deprecated, please use @link data stream execute and collect. So I'm not going to go through and do that for all of these right at this moment, but just making sure that our users know how to have a proper migration. The other thing we need to do, if I submitted this, it passed our check style, it passed our test, it would still fail. And the reason being, there is not one data stream API in Flink. There is two. There are two? I think there are two. I think there are actually three. There's also Python, but we're going to just ignore that for the sake of this talk. There's also our Scala data stream API. And so any method that we add to the Java API, we also need to add to the Scala API. So let's go in here. Data stream, there it is. And what you will see if you look at the implementation is that this is just a thin wrapper around the Java API, so I don't need to re-implement the code. We're simply going to add the method and call into it. For the sake of time, I'm going to go ahead and skip that. But the final steps would be to add that code. I would also want to add a little bit of documentation. So make sure that users know how to use us and that it is part of the Flink website. So our documentation lives in the main repository. And then finally, it is time to open our PR. And so I am very much out of time, so I'm going to go ahead and leave it there. But I would push this. I'd open a PR against the main repository. I would ping the committer who assigned me the ticket. And then we would go through the full process of going through the review and getting feedback and eventually getting our change merged in. So I am right at the end, so I'm going to go ahead and stop talking. But thank you all so much for joining. I'm not sure if we have any time for questions. And if not, I'm on Twitter always, so you can find me there.